Hello, today is lesson 12.1, series. Series and summation notation. Here's some definitions. When the terms of a sequence are added together, the resulting expression is a series. A series can be finite or infinite. So example of a finite series would be again 2, 4, 6, 8, stopping at 8. And the infinite series would be 2, 4, 6, 8 and keeps on going. You can use what's called summation notation to write a series. For example, the two series above can be written in summation notation as follows. If I look at this and I say, what's happening to my first term, my second term, my third term, my fourth term? What's happening to that? I'm multiplying each of those by 2. So here's our rule that we had to do in the last section. You still have to write your rule. Now you say, I'm starting at 1. We're always going to start at the first term unless it specifies. So this is term number 1, and I have 1, 2, 3, 4. 4 terms. This one, because it's infinite, it goes to infinity. Everything else is the same. So for both series, the index of the summation is I, and the lower limit of summation is 1. The upper limit is 4 for the finite and infinity for the infinite series. Summation notation is also called sigma notation because it uses the uppercase Greek letter sigma, written as sum, written as that S. Okay, when written in summation notation, the series above is read as the sum of 2i from values of I from 1 to 4. The index of summation does not have to be I. Any letter can be used. The most popular ones that you will see is I, K, and N. Now, when I'm putting it into my calculator, because I will show you, I always just put an X, so then I don't have to worry about finding any other letter of the alphabet. The index does not have to begin at 1. Usually when you end up writing the rule, it will, but if a series is given to you and you're asked to find summation, it won't always start at 1. And you'll see what I'm talking about because I have plenty of examples. Okay, so this says write the series using summation notation. So this is what I like to do. When there's a fraction, I like to say, okay, what am I doing to 1 over 1? What am I doing to 2 over 2? 3 over 3, 4 over 4. Why am I picking these? Because this is the term I have. This is my first term, second term, third term, fourth term. Now, I'm already going to write my summation. I said it starts at 1 unless otherwise specified, so this is my first term, and because of these dot, dot, dots, it's going to go to infinity. Now let's just look at the numerators. What's happening to the numerator? Nothing. If this is my first term, it's 1. This is my second term, it's 2. So my numerator is just n. Now my denominator looks like it's n plus 1, because if I take 1 and add 1, I get 2. If I take 2 and add 1, I get 3. So that is my denominator. This is my answer, and I'm finished. So writing rules is not going to go away this entire unit. So you have to become good at recognizing patterns, and the best way to do that is to practice. Okay, let's take a look at this one. This is my first term, second term, third term, fourth term, fifth term. Now, it makes me believe that there's some subtraction in this problem because this one is a negative and it's our first term, but none of these are. Obviously, just doing n minus 2 is not going to work because if I take 2 minus 2, I get 0. And that's obviously not right. If I take 5 minus 2, I get 3, not 23. So there must be something more to that. So if I take a look, I know my series is going to start at the first term. These 3 dots means it's going to go to infinity. And then I'm just going to play around and try to figure out a rule. Okay, let's look at, sometimes it helps to look at the bigger numbers. Now, when I see 5 and I see 23, I think 25. How do I get 25? I square it. So what if I take n squared? Then what? That appears to be 2 less. Let's see if this works. Let's do 4. 4 squared is 16. 16 minus 2 is 14. How about 1? 1 squared is 1. Minus 2 is negative 1. There we go. Okay, let's try another one. Again, this is my first term, second term, third term, and we don't know what term this is, but we have to figure it out because the series is not the series is not infinite. So we're going to start at 1, and we have to figure out what term we're going to go to. Okay, now, because I see a 3, a 9, a 27, this makes me believe I'm taking 3 and I'm raising it to a power. Because 3 to the first is 3. 3 squared is 9. 3 cubed is 27. So I do believe I'm taking 3 and I'm raising it to some power. Looks like to be the nth power. So what would 3 to what power would give me 729? It's actually to the 6th power. So this series goes to the 6th term. Now, there's an issue because this is negative, this is not. This is negative, and this is not. So why is that happening? Well, let's see if we take negative 3 and do this power to it. Negative 3 to the first is negative 3. Negative 3 squared is positive 9. So the odd powers would be negative and the even powers would be positive. This is it. Done. Okay, now I want you to try doing this one. This one is not too difficult. This is the first term, second term, third term. We have to figure out what term this is. We know we're going to start at the first term. We know it ends somewhere, so we have to figure that out, and then go ahead and try writing the rule. Take a minute to pause the video and do that, and then go ahead and move on to the next part of the notes. Okay, so this one says to find the sum of a series. We add the terms of the series. Be sure to use the correct upper and lower limits of summation when finding the sum of a series. Okay, so here's the thing. You can go ahead and do this by hand. Well, I don't know why you'd want to, especially when they get really messy. So let me just tell you how to read this. We're starting at 4 instead of starting at 1. So you're going to plug 4 in. When I plug 4 in, I get 16 plus 3, I get 19. Now you're going to do 5. Plug 5 in. When you do that, you get 5 squared is 25, you get 28. And then you're going to keep going until 8. Then, once you do that, you're going to go ahead and add up all the terms. However, there's a much simpler way to do this. So go ahead and pull out your calculators. Take a look. Now, there is a shortcut key for summation. So we're going to hit alpha F2. Oops, that didn't work. Alpha F2. Look at, see the summation key? It's the second one. So hit number 2. You're going to put in an alpha. Now what I like to do is instead of looking and saying, oh, I'm going to use K, I just put in X. Now be careful because when you do that, whatever letter you have here must match the letter you have here. So this one said it starts at the 4th term. Then I'm going to arrow up. It ends at the 8th term. And then I'm going to go ahead and put in my rule. My rule is 3 plus, it says K squared, but like I said, I'm going to use X because that's the letter I chose to put in right here. Hit enter. Done. The answer is 205. Let's try the next one. So if I take a look, this one was 205. Let's take a look at this one, okay? I'm going to go ahead and do alpha F2 again, number 2. So alpha F2, number 2. I'm going to put in X. It starts at 1. Oops. There we go. Starts at 1. Go up. This one ends at 4. And like I said, the original problem had a K, but because I used X, I'm going to put X. So we have X squared minus 5. Arrow over and hit enter. The answer is 10. Now, the next one looks a little bit strange because it has an I in the problem, but then there's no I for the rule. So let's try plugging it in. Let me show you what I'm talking about. See? There's no variable over here. So let's see what's going to happen when I plug that into my calculator. So alpha F2 again, number 2. I'm going to put in X, then a 1, then go up to 34, and then we're going to put in just 1. Let's see, are we going to get an answer? Look, we do, 34. So let's figure out what this means. So what this one is saying is I'm going to take the sum of 34 terms of 1. So 1 plus 1 plus 1 and so on, which is why we get 34. That's just something you might want to recognize. Go ahead, take a minute to pause the video and try on your own using the calculator. And then when you come back, we're going to talk about the special series. Okay, welcome back. So there's some special series that are helpful to know. You can always figure out a rule and you don't need to memorize them. I think it's helpful too because you will see some problems throughout this unit talking about even numbers and odd numbers. Okay, so let's talk about even numbers. The sum of the first however many terms of even numbers. Okay, so if I say I want the sum of the first 10 even numbers, you would do the summation, you would do n equals 1, you would do 10, and you would do 2n. Why? Because if I list the first 10, 2, 4, 6, 8, and so on, all the way till I get to 20. What are you doing to the first term to get 2? Multiplying it by 2. What are you doing to the second term to get 4? And so on. So this is something good to know because even numbers, the rule for even numbers would be 2n. This one is also good to know because it says the sum of the first so many terms of odd numbers. Odd numbers is 2n minus 1. I would definitely know this. So for example, 1, 3, 5, 7, and so on. What am I doing to 1 to get 1? If you multiply 2 times 1 minus 1, you get 1. How about what am I doing to 2 to get 1? 2 times 2 minus 1 is 3, and so on. So this is a good rule to know for odd numbers. And then lastly, this is that example that went with example number 3 above, the sum of n terms of 1. So if I want the sum of 50 terms of 1, I would plug 50 in here. But I don't need to put it in my calculator because the answer would be 50. Okay, any questions, comments, or concerns? Go ahead, write them on the bottom of the paper, and I'll see you tomorrow in class.